There's a lot of waste that come out of industries that keep the cogs turning in our society. But waste not, want not, because there are also a lot of people working to close the loop by turning that waste into new resources. Professor Kandis Leslie Abdul-Aziz leads the Sustainable Lab. Join us as we speak about science entrepreneurship and how we can engineer sustainable solutions out of waste in industry. I'm Michelle Ong, and this is Steam Powered. Good morning, Leslie. Thank you so much for joining me today on Steam Powered. I'm really looking forward to having you talk about your journey today.
Yeah, so thank you for having me. I'm happy to be here.
Yeah, amazing. So, we'll get started with your journey. And you began in chemistry, but what attracted you to that field?
Yeah, actually, it's very funny because in high school, I was never attracted to chemistry. I wasn't attracted to how it was taught and Bunsen burners and all these different types of things. And it wasn't until the last year of high school where I took a pharmacology class and I saw how biochemistry was really interesting and how drugs interact with our body. And so that really piqued my
Yeah,
interest because it was an application of chemistry. And so when I went to college at Temple University, that's located in Philadelphia, I majored in first biochemistry, but realized I didn't like the bio part. And then I decided to major in chemistry, which I've been really enjoying.
that's really awesome. So, where did you think you would be taking this, specialization in this field?
Yeah, when I was a student, undergraduate, I think a lot of people think, well, I'll be a medical doctor. So that was my first thought. And then I thought, well, I wouldn't be interested in the medical field, especially because I don't like the bio part.
Yep.
But I started to get into chemical research, in particular, using computers to do like quantitative chemistry. So, trying to
Nice.
predict what molecules would do when they're excited with light, but doing that using computer software. And I really loved that because that intertwined two things that I loved about the classes that I were taking in my major, which was math and chemistry. And
Yeah.
so I thought during that time, maybe I would become a chemical researcher after I graduate college. And of course, my career trajectory didn't take me directly there. Um,
Yep.
but that's what I was thinking about, that eventually I'll be a chemical researcher and study cool things about molecules.
That's amazing. And, so after that, you did do some research work, but then you went into forensics, which I think is
Yeah.
very cool. I love forensics. So how did that happen?
Yeah. So I decided to, after college, I just wanted a break. I didn't want to go directly into graduate school. And actually, it was supposed to be like a 1 or 2 year break, and it turned out to be 5 years. What I wouldn't suggest for a lot of people because it took a lot to get back into things. But initially, after I graduated, I worked at a chemical refinery, which was in a small neighborhood of Bridesburg in Philadelphia. And there, I was an analytical chemist for about 2 years. And then after that, I got into forensic chemistry, which was really cool. And my area of specialization was in drug chemistry. So every time an officer would make an arrest, they would retrieve either cocaine, marijuana, all of these different illicit drugs. They would bring it in and we would analyze them, analyze the composition, and confirm that they were actually illicit drugs or not.
That's very cool.
Mhm.
So, with that kind of work, I mean, it's obviously because it's an amazing application of the chemistry side of,
Yeah.
all the stuff that we do in the real world. But, was there anything in particular that, fascinated you most about doing the forensics?
I so you know, I never saw drugs before. So initially that was really interesting. So I was like,
That's
"Oh, this is
novel.
the yeah, this is heroin. This is cocaine. Wow, this is marijuana plants, a whole slew of them, sure." So that was pretty exciting at first. But
At
but I
first.
think yeah, at first. And then that actually became monotonous because then I was like, oh, heroin again. Oh, okay, cocaine again. All right. But yeah, so that was initially the exciting thing about doing this job was like it was applied chemistry, but wow, I
Mm,
was learning these different things. And I think what I most enjoyed about that particular position was learning about different drugs that were being used.
mm.
So Philadelphia at the time, that's the department that I worked for, started to get synthetic marijuana. So I
Oh,
was one of the first forensic chemists that developed a protocol in actually analyzing this because this was a new substance in the laboratory
yeah.
and a few laboratories were learning about, what is synthetic marijuana, what's contained in them, and it's actually very
Mm,
complex. And so I
yeah.
really enjoyed developing the protocol for studying that new illicit drug. So that was really one of the highlights of working at the forensic lab.
Yeah. And yeah, because you are going to be in a space where you'll be encountering all of these new things that are happening, you know, in society,
Yeah.
having access to the products to see, you know, what are people doing with these things? What is it like?
Yeah.
How do they make it work? Yeah, that to me is fascinating because people come with fascinating ways of doing weird things.
Yeah.
So as part of that, like you would have developed other things as well, and I think you developed these sensors for developing narcotics as well. Is that right?
Yeah. Yeah, so that actually occurred, in graduate school. So right
Ah,
after, so while I was a forensic scientist, while it was initially thrilling to see heroin, cocaine, and marijuana, after a while, it just got monotonous, and
and
I knew
tedious.
that yeah, and then I wanted to do more, and so I just decided to go back to graduate school, and I went back to, University of Illinois in Urbana-Champaign, right in the Midwest of the United States. And I, majored in chemistry. My goal was to earn a
Hmm.
PhD in chemistry. But at the same time, which was gnawing back at me, was what officers had challenges with while they were at one of the beat
Yeah.
and how that influenced chemists while we were in the laboratory. So one of the things was these officers, they would have these liquid tests to test illicit drugs. So if they
Mm,
expected that you were carrying cocaine or marijuana, they would use these little tests and they would tell them whether it's positive or not for that. The
yeah.
issue is that it has a high false positive rate. For
Oh,
some of those tests, it's above 50%. And
wow.
so, yeah, so we would get rare things in the laboratory that really wasn't drugs. There was a really famous case years ago in which organic soaps were tested as cocaine, and a lady was arrested at
Wow.
the airport for thinking that she, I
Fascinating.
guess, had bricks of cocaine, and actually it was just organic soap. Um, I've
Yeah.
I've received weird tests. I've actually received a bottle that was just filled with urine, but officers thought it was, PCP. And so that kept on gnawing at me because at the time that I was a forensic chemist, the Philadelphia department had a big backlog of thousands of
Yeah.
cases. And so I thought maybe if I can make this more efficient, that we wouldn't have this big backlog. We can be on top of these different cases. And so
Yeah.
and during graduate school, I started a company called Nardo Technology. Nardo, because I really, at the time, I admired Leonardo da Vinci because he had a very interesting life, very
Yes.
complicated life. And so I started that company, Nardo Technology, and it was essentially turning Android phones into chemical sensors. So we would attach
Nice.
an electrochemical sensor to the headphone jack of a Samsung Android phone or any type of Android phone
Yeah.
and interface it with a software. And that software will allow us to improve the results for drug analysis.
That's very, very cool.
Yeah.
Yeah, because it's one of those things where it is going to be tedious and time consuming, and there's so
Yeah.
much inefficiency in, all of that kind of work, and
Mhm.
you could be doing better things.
Yeah, yeah.
Yeah.
And, the idea was just to make officers' jobs easier. right? I mean, the
Yeah.
point of them using these little simple tests, even though they had a high false positive rate, was that they were very simple to use. And it would just
Yeah.
either tell them yes or no, whether this is what they expected it to be. And
Yeah.
so, I created that company with that goal in mind. Yeah.
Absolutely. Well, necessity is the mother of invention, right?
Yeah. Yeah.
So where did you go from there after you did invention? Like why didn't you pursue this, business entrepreneurial aspect?
Yeah. So I pursued that closer to the end of my graduate career. So, I graduated in 2017 with a PhD. I started the entrepreneurial company around 2015, at the end of 2015. And by the end of 2016, it became clear that it would be difficult to monetize this product. And this is
Yeah.
the reason why. So I went through this program. I received seed funding of like 50K, and it was really for customer discovery, understanding
Mm.
who would be in the market, who would purchase these, what's the ecosystem looks like if we did have these products out on the street with the
Yeah.
officers. And what we found was that, in particular, a lot of the jurisdictions had a lot of red tape. And that meant that
Oh.
new technology, there was a huge barrier for the adoption of new technology. And in fact, the use of new technology in the police departments here, um, somehow corroborated with huge public pressure. So, for example, the use of video
Uh,
cameras that
yeah.
police officers use on their uniforms, that was because of mainly public pressure. But
Yeah.
normally, departments are strapped for funds. And so any
Mm.
adoption of new technology is really difficult. So you have to try to keep the
Yeah.
product cheap and simple. And that's something that we wasn't willing to do, right?
Yeah.
And so we didn't find a way to make a profit by just pursuing law enforcement agencies.
Yeah.
So that's
That's really
why this,
unfortunate.
yeah, so that's why I didn't pursue it. But there's other avenues for the use of that technology. I just haven't pursued it.
Yeah, that's a shame.
Yeah.
Because yeah, like what do you do when you develop a technology that you can't use? Can you like would you on-sell it or do you just shelve the idea? Like just trying to figure out how that works.
I know. Yeah, I was so enamored with this idea and with this technology and make bringing it to fruition, that I was really down when it was finally decided that this wasn't
Yeah.
something that we should pursue. And so I decided to table that idea, in
Mm.
terms of thinking of other ways in which we can utilize that technology where it may be beneficial or maybe somebody might find it beneficial. Also, at the
Yeah.
same time, when I was created this company, I also had the idea, well, I could become like an independent researcher or I could be a faculty
Mm.
member, because a lot of professors are starting to get into entrepreneurship. And there were certainly
Yeah.
examples at the University of Illinois and at other institutions in which professors they did research and they also pursued their entrepreneurial companies, with a lot of companies coming out of their laboratories. And so I was like, well, I could
Absolutely.
still do that as well. And so that's why I decided to ultimately go into more of an independent faculty career and pursue entrepreneurship through this avenue.
That's amazing. So is that kind of what's leading you towards sustainable lab?
Oh, yeah. So so that's a totally different and exciting direction. So where
Yeah.
nanotechnology was inspired by my experiences as a forensic scientist, in Philadelphia, the pursuit of sustainability was really motivated from my experience as an analytical chemist at my first ever job leaving Temple
Oh,
University. Yeah, so I worked at a
that's cool.
refinery, yeah, in Philadelphia, and it was one of two major refineries. The refinery I worked at, we made fine chemicals. So we made like acetone, phenol, which is a building block to make like polymers. It's also in like medicines. If you ever have a sore throat, one of the active ingredients is phenol, and in other
Mhm.
different chemicals like that. And then we had a sister plant that was in South Philadelphia, and they made gasoline out of fossil fuels. Now, one of the
Yeah.
things that I noticed as working as an analytical chemist at the plant that in Philadelphia, so the other plant, was that we were right smack dab in a neighborhood. So if I ever walked past a security gate, I could see like a house not that far away. Like, yeah. So we were
Yeah.
like surrounded by your neighborhood. And, if I could smell phenol while getting out of the car, I could just imagine the
What it's like
residents
living
and what.
there.
Yeah, so I started thinking about that. One of my roles was to analyze our wastewater periodically, because we have to
Mm.
do that, because that's regulated, for running these
Yep.
different refineries. And I just noticed different nasty things that we were developing from fossil fuels to make these different chemicals were also getting
Mm.
into our wastewater stream. And so I
Yeah.
thought, there must be a better way in which we can have more of a sustainable um, economy where we could still have these different commodities like plastics and fuels and different technologies where we're not also hurting the environment and eventually human health. And so that
Yeah.
really motivated the development of the sustainable lab.
How do you transition from a chemist to becoming a materials and chemical and like environmental engineer?
I know. I kind of feel like I had just said that. I kind of feel like a imitator or something. I'm not like I had just went to a dinner for chemical engineers. I just came from this conference for chemical engineers, one of the largest conferences. And I was having dinner with somebody I just met. He was like, "I got a dark secret. I'm actually a solid state chemist." And I was like, "Me too. I'm a chemist too." So, but I knew early on with developing this laboratory. So the thing about chemistry is that you have to be really enamored and in love with the science and really understanding a lot about sort of the minutia of the
Mm.
chemical reactions, for example. But I was more interested in more of the applied stuff. So,
Yep.
what, kind of things we can learn from chemistry that will actually be applied in society or be useful for, me, you, and our families and friends to use. And so that really changed my mindset from being just a chemist, also my experiences at the refinery, from just being a chemist and to being more of an engineer and engineering products that and
Yeah.
processes that would be useful and applied to our society now.
That's very cool.
Yeah.
So to be able to make that shift, are there any do you have to go back to school? Do you need to kind of do a master's, or how do you redirect down that route from having, your professional background being chemistry?
No, I mean, the having the background of chemistry, I think, is really beneficial for being an engineer. I consider myself an engineer as well, even though I wasn't
Yeah.
classically trained as one. And I think definitely the way that I think of problems certainly helped me fill in this engineering role. So if there isn't any further education. Trust me, I'm learning. I definitely learning.
Learning heaps all the time.
Yeah, all the time. Um,
Mm,
but so there's no further education needed, but certainly the types of problems that we go after are more engineering endeavors instead of
yeah,
just like a chemistry type problem. Yeah. But
absolutely.
I would like to say that the positive of having a chemistry degree is I really have a appreciation for fundamentals and understanding like the chemical reactions and the different minutia of that and applying that knowledge to developing better products and processes that will be helpful for society. So I think it is a benefit to come from a chemistry background.
Yeah, because you develop those experiences. You've seen these things out in the field and
Yeah.
are aware of where the shortfalls are and where the improvements could be made. Yeah, it's fascinating because so many people think that, a life and a career is A to
Hmm.
B. You do chemistry, you become a chemist. But because, as you said, there's so many parts of it. There's, the pure analytical aspect, the lab aspect,
Hmm.
but there's also the applied aspect. And it's where you want to put that focus, which will direct you down the path of, analyst versus engineer and all these
Yeah.
other areas that you can explore.
Yeah.
Yeah.
Yeah, I totally agree.
So when you eventually came to starting Sustainable Lab, what were the ideas, aside from things like what you experienced as an analyst, what were some of the things that you wanted to bring focus to for research?
Yeah, so that's a great question. So one of the things that I really like about chemistry is the applications to material science and how important that is to develop new materials. In particular, I wanted to develop better catalyst materials. So, like the refinery that I worked at, in order for us to convert fossil fuels to plastics, to acetone, to all these different fine chemicals, the main way we do that is the development of catalysts, and these are either
Mm.
nanoparticle materials or molecular structures that have the capabilities of speeding up chemical reactions really fast so we can make all of these really nice chemical commodities. And I wanted to utilize material science and chemistry to make better catalysts. So that's where we have more of the applied part. And not only that, make catalysts that can make these same chemical commodities that we make out of fossil fuels, but make that out of renewables. So make it out of
Yeah.
biomass, so agricultural waste, make it out of greenhouse gases. So it was really about still having us maintain the level and technical aspects of our society, but getting those products, our technology, our fossil fuels, all these fuels, not fossil fuels, but fuels and different things um, from renewable resources or from generally waste.
That's awesome. Yeah, and it's closing the loop because so much of the stuff that we do, like agriculture is a massive part, right?
Yeah.
Without agriculture, we don't have a society, we can't eat.
Yeah.
And, being able to close a loop
Yeah.
on some of those side effects of that industry is such a massive problem that a lot of people are trying to solve today. So, I see that one of the things that you're working on is converting CO2 and methane into biofuels.
Yeah.
So, aside from, in my head, the agricultural kind of applications, what other applications are there in different industries where that would be a thing that they need to use?
Yeah. So we're primarily looking at two of the biggest greenhouse gas culprits and turning them into building blocks. So I think this field is really exciting. We talk about climate change, we talk about carbon capture, and eventually storing it underground. And
Yep.
that we don't know what will happen by just storing a lot of CO2 underground. Who knows? We might turn
Mm.
into Mars. But um, the premise for the sustainable lab is let's capture the CO2 and methane out of the air, but let's make very useful items out of those as well. And
Yep.
so one of the things that we've been looking at is turning it into fuel. So you could turn CO2 and methane into like hydrogen if you want, or you could turn it into like a even into gasoline through other subsequent downstream reactions. One of the things that we're really excited about is trying to convert CO2 and methane into ethylene. Now, ethylene is a really important molecule. It's a very important building block for the chemical commodity industry because you could build so many different things from that. So, like from ethylene, you can make ethanol. Like, there's one reaction that you could do to make ethanol, and that's very important for a lot of different aspects as well. But also from ethylene, you can make different polymers like polyethylene or polyethylene terephthalate, which is typically used to make water bottles. So, we're trying to really make this building block material or molecule so that we'll be able to make all of these different finished products. And that's one of our main focus right now.
That's awesome. Like, I just love how broad that application could be. I mean, because all of that stuff, like you said, it's a building block that's used everywhere in so many
Yeah.
different ways. And we have a ton of CO2 and methane to,
Hmm.
start working with as a foundation. Like this is very cool. I'm very excited about this.
Okay. Thank you. It's very cool, but it's also very challenging. And so
Yeah.
that's where the chemistry part becomes important because A lot of the chemical reactions that we utilize that can convert these greenhouse gases into these building blocks, the selectivity to those particular products, like to ethylene, is very low. So how do you develop a
Yeah.
material that can improve sort of the output of this particular chemical that we want? And so that's really the
Mm.
exciting part, where a lot of chemistry comes into aspects of like, how do we optimize this nanoparticle to do these special chemistries? How can I influence how this different CO2 molecules are impinging on the surface so that we can create the right product? So I think that's really the exciting part, is that it's very challenging to do. It's not very
Yeah.
straightforward, but it's very, very interesting to try to incorporate all of these different things: chemistry, material science, chemical engineering, into making this optimal material. Yeah. There's another aspect that we're looking into, and that's really what can you do with agricultural and plastic waste. So plastic
Ah.
waste has really gotten into the news recently, but it's really been an exciting thing for the catalysis field, because what we realize, especially in the United States, like less than 5% of our plastics are actually being recycled. And so
Mm.
95% of that plastic is going elsewhere. Most likely it's ending up in the landfills or ending up in our environment. And
Yeah.
now there's talks of like microplastics and all of these things influencing our bodies. And so one of the things that we're looking at is there an alternative approach to recycling? Like plastics, for example, can you basically break down these plastics into building blocks of chemicals and then use those as a building block as well to make other useful chemicals? So that's what we're
Yeah.
trying to do right now. So we're developing different pyrolysis processes. That's essentially when you heat up the material in a very inert environment that doesn't have any oxygen, and you could
Mm.
convert it into a carbon substance and also an oil that comes out of it. Now, the carbon substance we've been studying for its efficiency for water filters, which we find has
Mm.
been very useful in removing different industrial pollutants out of wastewater. And so that's something that we're actively
Nice.
looking into now. And I'm also looking into going into starting a company there. So that's the entrepreneurship part, in which we're actually
Yeah.
turning a waste product into something that's useful for society. And then on the other end is the oils that you can utilize from it. You can actually upgrade that into a variety of different things like gasoline and different products. So we're really excited about that approach as well.
That's amazing. Yeah. I love that. There's so many different avenues to explore with
Hmm.
this, and they all have the same foundations of, yeah, just taking the waste that we have in society through in the air and through, byproducts of industry. And yeah, again, being able to close the loop on that system to try to,
Yeah.
yeah, make that reusable, and
Hmm.
also reducing the amount of overall waste that's going out. It's amazing. I
Yeah.
love it.
Yeah. 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 Because we're very wasteful. And all of
We
these
are.
things are going in a landfill, and we're talking about greenhouse gases. One of the major greenhouse gases that come out of landfills is methane. And so when
Yeah.
we have a lot of that in the air, that really contributes to global warming. It's even more potent, about 20 times more potent than CO2. So the
Mhm.
waste that we're generating is actually bad for the environment, and it's getting worse and worse. And so what we're trying to do is seeing if we can, like you said, close the loop and develop an economy where we're utilizing that waste for reuse or making it into
Yeah.
something else that's valuable for us to use as well.
That's awesome.
Yeah.
Yeah, so just recently I spoke to another scientist, and one of her areas of research previously was breeding low methanogenic clovers
Hmm.
because it's a massive grazing crop for livestock.
Oh,
So if you can
wow.
reduce what's coming out as well, so it's like taking, literally catching the problem at both ends.
Yeah. Okay. No. Yeah. That's really interesting, and Yeah, I have people have
Yeah.
talked about, how do you reduce methane emissions from like cows and maybe have them
Yeah.
wear like masks or something. It's just really interesting ideas coming in that field as well. But
Yeah,
yeah, yeah.
absolutely. Yeah. It's clearly a bigger problem that a lot of people aren't aware of. Then we can start to wind up with those
Okay.
other questions that I mentioned.
All
So,
right.
what sort of hobby or interest do you have that is outside of your field of work?
Okay. So that's really interesting because I'm a very boring person. However, when I
Not
was
boring.
younger, well, thank you. But when I was younger, I was I played the classical bass, so the upright bass,
Oh, cool.
and I actually purchased one, and so I'm trying to get back into that again and just play it.
Oh, awesome.
That's one of the hobbies that I'm trying to get into. Reading more too. I love sci-fi novels, and I'm also a gamer. That's what I do in my downtime. Before this interview, I
Oh,
was playing
that's cool.
Overwatch. So yeah.
Ah,
So
nice.
yeah,
That
yeah.
is
Those
very
are three
cool.
things I like. Yeah. Thank
Yeah,
you.
varied interest. There's nothing boring about that at all.
Okay.
That's
Yeah.
cool. And which childhood book holds the strongest memories for you?
The childhood book that holds the biggest memory for me is called Song of Solomon by Toni Morrison. And it was one of the first books that I read that introduced more of like African American heritage with some sort of like superstition in a very interesting way. And I wouldn't say it's like it's more like teenage book because it was a required
Mm.
reading in high school, but I really liked that book from Toni Morrison because it really introduced like the supernatural and African American heritage. So I really enjoyed that book. Yeah.
That's awesome. Gonna have to look that one up now.
Yeah.
Cool. And what advice would you give someone who would like to get into the field that you're in, and what advice should they ignore?
Oh, okay. I think if you are interested in getting into the field of chemistry or applied chemistry or chemical engineering, definitely pursue it. We need more diversified voices in cultural backgrounds and faces in this arena. I think it's definitely beneficial. I think I'm a testament to seeing how my personal background working as a chemist, seeing how these refineries that are centralized in different neighborhoods were influencing those local people as well. And I think that
Mm,
ultimately is what motivated me to get further in this field, to go from chemistry to more of an applied aspect, which is engineering, or what some
yeah.
chemists would say the dark side. But I would say definitely pursue it. And my other suggestion is not to follow or listen to the naysayers. Engineering or chemistry is inherently difficult. So if you find something difficult to understand, please ask somebody. Even scientists,
It's
we have to
normal.
we YouTube and Google before before I prepare those lectures for my students. I'm Googling. So,
Yeah.
it's okay. If you have to do that. It's a naturally difficult major or interest, and so if you find that it's too difficult, I would say definitely just push forward, try to find help, try to find tutors, utilize YouTube and other resources, because honestly that's what we're doing too. So
Yeah.
yeah.
Exactly. And so many people forget that, yes, in exams, we don't have those resources in the real world.
Yeah.
We've got Google. You know,
Right.
we're going to look things up. We're going to be
Yeah.
asking other people for help. We're going to be,
Right.
you know, needing the collaborative experience of
Yeah.
learning in order to get further in what we're doing.
Yeah. Yeah. Exactly.
Yeah. And because you went into, industry before returning to academia,
Yeah.
did you struggle with that transition back from, going from working out in field and coming back in through to research?
Yes, I did. Um, so, actually, the summer before starting the graduate program, I went to the library daily, and relearn simple things such as calculus or,
Mm.
even basic chemistry again, because one if you don't use it, you lose it, right? And so I had to
Yeah.
regain that knowledge again. And so the summer before, I had to prepare myself for the onslaught of graduate classes. And then once I went through the graduate classes, I wasn't used to staying up to 1 a.m. to complete homework assignments. And so I had to get used to that type of schedule as well, because I was used to the 9 to 5 uh, type
Yeah.
of work schedule, and you wind down, go home. But I would say that first year, after transitioning from an industrial position to graduate school, was probably one of the most difficult, because I had to really catch up on knowledge in the chemistry field. Yeah.
Yeah. Absolutely. Like it's such a massive change into a lifestyle and quality of life.
Yeah, it is.
Yeah.
And those classes were rigorous. And so I really had to, figure out a way. So I would reading multiple books and things just to catch up that first year.
Yeah.
So yeah, I would say it was a very difficult transition, but it only got better longer along the graduate program. So yeah.
And it's very cool that, you've had this experience being an entrepreneur as a scientist,
Hmm.
because so much innovation is coming out of all of these fields, and being able to put them back into society somehow is, ultimately the goal really of
Yeah.
any scientist and researcher. So it's not entrepreneurism isn't really a thing they teach you at school in a formal way. Not yet. They're getting there.
Hmm.
So, as a scientist, what sort of things how did you go about getting into, starting your own business, becoming an entrepreneur, and, setting up the company? How did you learn to get into that space, especially with grants and research and getting support for all that kind
Yeah.
of stuff?
Yeah. So I got into entrepreneurship while I was a graduate student at a University of Illinois, Urbana-Champaign, and they had this great resource of the startup incubator that had these different workshops and ways to get involved that would teach you how to start pitching your idea, how to build a business plan, and we even had the opportunity to go to Silicon Valley and visit other startups that were either software or hardware startups, and they were also alumni of the school and how they were doing. And so
Mm,
I really would say that the resources at the school was very beneficial for me to get a glimpse of how to transition from thinking like a chemistry PhD student into a entrepreneur or a potential CEO that is trying to sell first this idea and hopefully build off of this idea a successful
yeah.
company. So yeah, I totally agree with you that those resources aren't naturally available. But one of the things that I'm doing now as a professor is I'm trying to make them available for engineering students here at the
Yeah.
University of California, Riverside, in terms of developing workshops for our engineering students. And so they learn these different skills because I think it's really important. You learn how to be a better communicator. You learn how to develop products that goes from the laboratory to actually in somebody's hands or potential uses. And I think that sort of mental exercise is both beneficial if you're trying to start a company, but it's also beneficial if you are a part of a company as well. Like if you're
Yeah.
working for Microsoft, how do you innovate a new product? Or
Mm,
any other company, how do you become entrepreneur as well? So you don't have to be entrepreneur,
yeah.
but you could be entrepreneur. So that's one of my efforts now as a faculty member, is just trying to share these entrepreneurial skills that they learn, and they can start companies if they like, but they can also be more entrepreneurial at whatever position that they go after they graduate.
That's amazing. Like, it's such an important skill set to learn.
Yeah.
And especially with, academia, it's not easy. But all of the skills that you develop as an academic and as a researcher are all completely transferable, because, at the
Hmm.
higher levels, you're running labs or you're running teams, you've got to do
Yeah.
project management, budgets, and all of these things. And
Right.
these are all skills you need for entrepreneurship.
Yeah.
And it's just changing or learning to adapt your mindset from lab focus to an external focus. And as
Mhm.
you said as well, entrepreneur, being able to figure out how you can apply those skills internally
Yeah.
to meet that greater goal.
Mhm.
So important.
Yeah. Yeah, I agree, and, like you said, there's not that much resources, but, we're trying to develop that so that, students who are interested in entrepreneurship can pursue these different things, these different resources, and there's lots of them right now.
Amazing. Love it.
Yeah.
Oh, this has been so great. All right. So, yeah, thank you so much, Leslie, for speaking with me today. This has been absolutely wonderful. And I've loved hearing your journey because it is indirect.
Yeah.
But, you've had experience in industry, entrepreneurship, developing, being an inventor,
Yeah.
because, there's so much capacity for invention in all of these fields, no matter what capacity that, we have in it.
Yeah.
So if people would like to learn more about you, your work, where can they go?
Yeah, so if you're interested in learning more about my work, you can go to our laboratory website, which is the dash sustainable dash lab.com. And if you want to follow me on Twitter, I'm at the waste not lab. That's my Twitter handle, or maybe not. That might be taboo now. I'm also on I'm also on Mastodon as the sustainable Khaleesi. So if you want to follow me on Mastodon,
Nice.
you could do that as well.
Love it. All right. Well, thank you so much again, Leslie. This has been absolutely an amazing conversation, and I hope you enjoy the rest of your evening.
Yeah, likewise. Thank you for having me, and I hope you have a great
Uh,
evening as well.
yeah, it's been an absolute pleasure. To learn more about Leslie and what we discuss on the show, or to connect with us, please visit the Steampowered website at steampoweredshow.com. You can also find the Sustainable Lab at the-sustainable-lab.com and Leslie on Twitter at the Waste Not Lab and Mastodon, the links for which will also be in the show notes. If you enjoyed this conversation, please let us know. Subscribe to the show, leave us a rating, and share this with your geeky or geek-curious friends. You can also support Steam Powered on Patreon and the Steam Powered Show, the links for which will also be in the show notes. Thanks for tuning in, and we'll see you next time.